Hello, my name is Jonathan Bisnat. In this video I'm going to look at something called a magnetic reed switch. It's switched using a coil, and here's some examples of them here. So here's the actual switch, and you'll see it's basically a coil. I've got connections to both ends of the coil, and then inside the coil is actually this reed switch. I've got one here I've taken apart so you can see the coil. You can see that it's hollow through the middle. And then here is the switch. And it's actually got, and I don't know that I can get you close enough or focus well enough here to actually see, but there are two pieces of metal in there and they don't quite touch. Probably the closest I can get is that, and you really can't see it. There's two pieces of metal in there and they don't quite touch when there's no magnetic field. When a magnetic field is applied, those pieces of metal are pulled together and create basically a short through this device. So it operates like a switch. This is a sample of a circuit that I built using this magnetic reed switch. And what you'll see, basically I've got my inputs here from the power supply that go to both my rails, and I've connected them across. And really what I have over here in the middle is a potentiometer, which is tied to both power and ground across the ends of it. And off of the wiper here is basically a piece that is a connection that goes through this white wire to one side of the coil here, and then off the other side of the coil another white wire that comes back around through this resistor and back, through this resistor and back to ground. The red wire up here goes to a meter, which I'll show you some stuff on later. And then the rest of the circuit, you'll also see that there is what's called a flyback diode here. This basically deals with the inductive kick when this coil, or inductor in this case, when the magnetic field breaks down, a fairly large spike occurs, and this diode allows that spike to dissipate back through the coil rather than burning things up in the circuit. The rest of the circuit, you'll see here, this orange wire here comes off the power and goes into the coil there, right in, connects in the same point, goes into the, not into the coil, into the magnetic reed switch. And out of the magnetic reed switch on the other side, we have another orange wire, which then comes up here, goes through an LED to ground. So basically very simple, just light an LED type circuit, but as you'll see right now, the LED is off and the voltage at the center point of the pot is 0. So as I come here and I turn this pot, it's going to have to go a fair amount of the ways. So as an example, I'm now at about just over 2 volts here. You can see. Still no light. I have to hit about 3.5 volts. Oops, sorry, my screwdriver's coming out here. I have to just about hit 3. There it goes, comes on. Actually, it's even a little bit less. Came on at about 3.2 volts. The light lamp comes on, and it's actually got a little bit of hysteresis. Once that switch is connected, it will remain connected a little bit. So actually, as we back down, I can go back down to, well, there it went off. Let's do that again. Okay, so if I come down here, as you can see here, I'm down about 2.4, 2.5, and the light is still on. So it goes down to, there it went out, just about 2 volts. So you got a bit of hysteresis in here that basically once it's connected, it stays connected until you drop far enough for it to actually disconnect. But it's a relatively simple circuit. I've got a picture of it here, and I will show you this circuit. again, what you'll see is pretty much what I described. So you've got your pot here connected between 5 volts and ground, and that's all I'm using to energize this particular coil. Other coils may be different. This one is simply 5 volts is sufficient. Off the wiper of the potentiometer, you'll see I come into my coil here, and I've kind of drawn the combination piece in this dotted square, or dashed square, I'm sorry, to give you an indication of where the actual reed, switch, and coil are. And then connected outside around the coil, you see my flyback diode. This is to basically deal with the inductive kick. And then below that, I've got a 220 ohm resistor just to basically limit current through the coil. There's technically some up here in this 10K pot piece as well, but just to kind of make sure we're good, especially if I were to take this all the way up and give it the full 5 volts, safety dictates I put something in there to control current. And then you'll also see for my other circuit, I'm coming off the 5 volts, coming through that magnetic reed switch, which is normally open, with my LED and 220 ohms to ground. So, as I say, very simple circuit, more just to give you a feeling of how a magnetic reed switch works. Hope you found that interesting, and I will put this schematic and picture up on the, or I will specify a link to it in the description of this video. Thanks for watching.